Hey, everybody. Dave Lindberg in Hong Kong with another episode of the THD Podcast. Today, joining us from Denmark, we have ICEpower to tell us all about their amplifiers and what makes them unique. So, as always, joining us from Japan, our co-host, Simon Weston. How are you doing today, Simon?
Very good. Thank you, Dave. Looking forward to this one.
Okay. All right. And Emil Solgaard, Director of Sales and Marketing, calling in from near Copenhagen. How's it going over there today, Mads?
It's going well. Thank you very much.
Okay. So yeah, ICEpower's got a bit of a history connecting to some famous Danish audio lineage. So if you could, maybe let's start with a bit of the history of ICEpower and where you came from.
Yeah, sure. So, well, basically, I mean, we've been around since 1999. And initially, you can say the company was founded based on some research done at the Danish Technical University into how you could do more efficient, more compact, more energy efficient amplifiers for audio basically, and that resulted in a bunch of new innovations around Class D amplifiers. And you say back then, Bang & Olufsen, the Danish audio company, they were very interested in doing active speakers, with a very compact form factors and very unique design. So for them, it was very interesting to have this new technology, where you got great audio quality, but at the same time, we're able to really package a lot of, amplification and a lot of power in a very small space. So they invested in you can say, in the company, and that meant that to begin with, the company was a joint venture between the original inventors of the technology and Bang & Olufsen. And then you can say during those years, it was a big benefit to be part of the B&O group because, first of all, it's always nice to have a lead customer, obviously, but also you can say there was a lot of, heritage, a lot about quality, a lot about processes, and how do you, one thing is having a technology, but how do you actually productize that and create a stable and reliable product? And obviously they had lots of processes and competencies around that. So, for a startup company, it was a great, infusion of competences to have to begin with. But then over the years, you can say the focus of B&O and ICEpower kind of diverted somewhat, whereas they went in one direction, we started to move in another direction. And that meant that some years ago, it was a decision that it didn't really make so much sense anymore for ICEpower to be part of the Bang & Olufsen group. So since 2016, I believe, we've actually been an independent company, and that's been a very positive thing for us. So that has allowed us to be more, you could say, have much more flexibility, more freedom in terms of how we operate, what markets we choose to serve, and so forth. So that's been a bit of the background. So really, we came from strong focus on the Class D amplifiers, which is still what a lot of people know us for. But over the years, we've kind of evolved also because you'd say the Class D amp is just one part of the package, right? So switch mode power supplies is also a very important thing if you want to do compact audio solutions. So that was another technology that we very quickly also added to the package. And then since then, we've also been building up competences and have been working in many other, audio technology areas, both including digital signals processing, and you can say network audio over IP, mechanical engineering, etc. So today you can say we don't see ourselves just as a Class D amplifier company. We see ourselves more as a solution provider of complete turnkey solutions to the audio industry.
Okay, so it sounds like
when you're starting out to. I just wanted to, when you're starting out developing Class D amplifiers, is that a complete silicon chip? Are you doing silicon design, or are you implementing other chips to get the Class D amplifier?
It's both, to be honest. I mean, we've done I think around 12 different silicon designs over the years. We've done them both for, we several years ago we were one of the first companies to introduce Class D amplifiers for mobile phones. So we did several designs there that were used by Samsung back then, and they used it in, I don't know, hundreds of millions of mobile phones back then. Also done some silicon design for televisions with some of the Japanese television manufacturers. But then, of course, also we've done several silicon designs for ourselves, basically, for the Class D amplifier modules and complete products that we do ourselves. So there's we have a long history of doing our own silicon, but we also work with other companies' silicon, like, if there are, sometimes there are good reasons to do so. It all depends on what is the particular application, what are the particular customer and product requirements for a particular product, and then we choose the solution that fits best to that application.
Okay. Maybe I think you prepared some slides, so maybe if some of the slides could help illustrate the technology and go through how the evolution has happened, maybe that'd be a good place for us to continue the discussion.
Yeah, sure, absolutely. So we prepared a few slides. I don't know, are we sharing those yet, or?
Yeah, here we are.
Great. So I guess you can say, so basically I put together a few slides here, and basically my hope is that when we're done with this interview, then I've been able to shed a bit of light on who we are, what it is we do, and how we help companies in the audio industry achieve, you can say, a competitive advantage in the marketplace. And then, so let's go through this. If you give me the next slide, please. Oh, sorry, I actually have a little clicker here.
Mm-hmm.
So I'm gonna talk a bit about why customers work with us, what it is we offer. I'm gonna talk a bit about some facts about who we are, etc. Talk a bit about some of the resources, capabilities we have. And then go a bit more into detail on some of the products and services that we offer.
Okay. Actually, I just wanted to mention ICEpower. ICE stands for something, doesn't it? It's good. So
that's true. Yeah, that's a good point. I should have mentioned that as well. So you can say it's kind of there's kind of two meanings to it. So of course, it means ice because it has you could say connotations of being cool and cold, because it's energy efficient and it doesn't produce a lot of heat, so it's cool power. But on the other hand, it also stands for intelligent, compact, efficient, and powerful. So there's kind of a dual meaning to it.
Okay.
It kind of sums up, that it was a bunch of, you could say, it was the original idea was a lot of new technologies enabling, you could say, advanced and intelligent design that allowed us to do very compact and efficient amplifiers. That's kind of the genesis of the company. Good. So of course today we've been around for, as I mentioned, almost 20 years, and that means that we talk to many different customers in the audio industry, and some of the things that we keep hearing from customers are usually variations over the following statements here. So typically we hear statements such as, you can say, there is more and more products coming into the market. We need to be able to develop faster. Time to market is becoming really important. But at the same time, it's a product complexity, technology content in audio products is increasing. There are more and more requirements for wireless, Bluetooth, Wi-Fi, audio over IP, control over IP, different sorts of web interfaces, GUI control of products, all that sort of things. And a lot of the companies we talk to also, they all seem to realize that, you say, engineering bandwidth really is a limitation. Even though even some of the largest companies in the industry that have very large engineering departments, lots of engineering talent, they always seem to have, you could say, more product ideas on the roadmap than they do engineering bandwidth. And a lot of the companies today that we talk to, they've kind of moved from you could say the more traditional approach of wanting to do everything themselves and being controlling everything throughout the entire product, to a realization that it's important to really focus on what it is they're good at and what it is that really differentiates them as a company and differentiates their products in the marketplace. Okay. So basically you can say why we can help is we have a very broad audio IP portfolio that we've been building up over the last 20 years. So of course, it's Class D amplifier technologies, but it's also switch mode power supplies. It's DSP processing. It's audio IP. It's many different things. We also have lots of existing, you can say, audio technology platforms, both as again, existing power supplies, existing amplifiers, etc. Then we have a large pool of, you could say, great audio engineers. I'm very proud of our engineering team. And that in combination, you can say, with a very competitive manufacturing setup in Thailand, means that we are able to help our customers essentially create and get innovative, cool products to the market fast. And you can say, of course, there are other companies out there that offers different sorts of audio IP. There are other companies out there that have amplifier and switch mode power supply platforms. There are also, many other good design houses out there that have good audio engineers, of course. I think one of the things that makes us unique really is the combination of all of these things together, because that really makes us a complete turnkey one-stop shop for audio product development.
And I suppose that the experience in going from amplifier to product and the integration, there's always a lot of gotchas between amplifier and power supply and the wireless technology that's used, and you probably have some skills that cross over to having experience in-house on how to solve these issues each time, which helps speed to market.
Yeah, absolutely. I mean, it's that's also always been one of our, you can say, mottos, that you can say, creating good audio. It's not about the individual components. It's about the system, right? So it's not just the amplifier. It's not just the power supply. It's not just the DSP. It's how you put all of that together. It's not just the transducer and the acoustic element. It's a combination of all of those things into a complete system. That's also why we are, you could say, why we've moved towards, as I mentioned before, having all of those competencies in-house instead of just being a specialist on amplifiers, for example. Okay. Yeah. So that was just a bit of an intro to what it is we help our customers accomplish. So I'd like to continue with just a bit of facts about ICEpower, just a bit of background. So basically, as I mentioned before, we're based here in Copenhagen, in Denmark, and as I mentioned, that originally was because the foundation of the company really was some research being done at the Danish Technical University, and it's been a very good place for us to be, because you could say Denmark actually has a very big audio industry, and one of the reasons for it, of course, is bang&olufsen, but there are many other very well-known brands in audio in Denmark as well. And also we have actually, I think it's 3 or 4 of the 5 largest hearing aid companies in the world actually based in the Copenhagen area. And that really generates, as you can imagine, a lot of demand for audio engineering talent in many different regards. And that means that the Danish Technical University that we have a very good collaboration with, they do lots of research and they educate lots of really talented audio engineers, both in, you can say, digital signal processing, power electronics, switch mode electronics, audiology, psychoacoustics, pretty much all of the different fields of audio and acoustics. So from that perspective, it's been a really good location for us to be in as an audio company, because there's been lots of talent there's a big talent pool for us to tap into, basically. Mm-hmm. But at the same time, of course, it's also very important for us to be close to our customers. So that's why we also have, you could say, local customer and application support, both in the US, in Japan, as well as in Taipei. But of course, trying to manufacture in Denmark would be prohibitively expensive. So in order to be competitive, of course, we've outsourced all of our manufacturing to partners that are specialists in manufacturing. And today we do all our manufacturing in Thailand, in Bangkok.
Okay. And was there a reason for Thailand over China? Is something you might be able to mention?
Well, I mean, actually, Well, to be honest, 20 years ago, we actually did start manufacturing in Denmark, and very, very quickly learned that was not really the way to go. So initially we moved production to Malaysia back, that's probably, I don't know, 18 years ago. We were then in Malaysia for a while, moved to China, moved back to Malaysia, and then we moved to Thailand. And and you can say the reason for it was, I'd say a collection of different things. It was both about the specific partners that we chose there. I'll get back to who they are later. That we had, we found some partners that we thought were a very good match for us, both in terms of their size, their setup, their mentality, etc. But also we found at that time, and this is probably 6-7 years ago, we found at least that that Thailand was competitive and actually on many regards more competitive than China, where we were before.
Okay.
And then, of course, you can say with the whole tariff situation that's been, especially in the US in the last couple of years, being in Thailand has definitely not been a bad thing for us compared to customers that are mainly building in China.
Yeah, and especially being there early and not rushing in the last years to try to alter your price structure. Okay.
Yeah.
So your products are actually consumer level goods, or they're finished goods rather than just PCBAs or chips.
It's actually all of the three, all of the above, basically. So we actually do both chips, and I'm also going to get back to that. We have customers that basically just buy our chips and build themselves.
Mm-hmm.
We have customers that buy our PCBAs, our modules, essentially. And then we have customers where we build complete products for them. So it really is a mix. And then we actually also have customers where we just provide them software. So it really is a mix of those different approaches.
Right.
Okay.
Yeah, and then I think I just counted yesterday, and as of today, we are at 64 employees, all of which, or most of which, are engineers.
Fantastic.
Mm-hmm. Yeah, so the customers we work with are basically, of course, there are also other specialist segments. We also, but the majority of the customers we work with are in 5 different segments. So pro audio is a big market for us. Obviously, in 2020, it's been somewhat impacted, I would say, by the whole COVID situation. But if you look at the picture here in the bottom left corner, when you look at a stage like this, pretty much all the products on there are product categories that we help customers build. So anything from line arrays, amplifiers for line arrays, to bass amplifiers, guitar amplifiers, stage monitors, etc. Is a big segment for us. And so is, if you look in the top left corner here, studio monitors, both for home studio usage, which of course has been quite a very successful segment during this whole lockdown period. But also you can say more traditional in-wall big main monitors for studios. Then we do lots of we have many customers also doing, you can say, consumer hi-fi audio. We have many customers doing home automation. So let's say those are typically big rack amplifiers for multi-room audio installations. But we also do a lot of products for the commercial installation space. So restaurants, bars, shopping centers, etc. And then in addition to that, we work with customers in, you can say, the portable electronics industry. So we work a lot with Asus computers. They basically use our software on pretty much all of their notebooks. We also work with different manufacturers doing smartphones and doing tablets as well. They utilize our DSP processing software. And then, of course, if you buy a premium car like the Aston Martin here in the bottom, then you also get the benefit of having a nice ICEpower amplifier as part of the OEM sound system. Please support us and go buy an Aston Martin. We'd much appreciate it.
Yeah. Us and James Bond.
Yes.
We're in the queue.
Exactly.
So you're actually doing products that are very high power stuff, PA, or if you got down to very low power stuff. From your point of view, is it all the same thing? It's just scaled up and down, or are they completely different design fundamentals?
Well, it's It's a yes and a no to that. So the core technologies we use are the same. Basically, the core, you can say, physical principles are the same. But of course, the implementations vary a lot between whether you're trying to do a 50-watt amplifier or multi-kilowatt amplifier. For example, if you look at the switch mode power supply topologies, you could say there are many different topologies, and and the topology that is a good choice for a low power design is not necessarily the same topology that is good for a high power design. So
right.
so we've pretty much worked with all of the different power supply topologies, really depending on what is the application we are looking to do. So we've done flyback converters, we've done forward converters, we've done LLC converters, we've done PFC boost converters, all sorts of different converters, each for each particular application.
Right.
And the same thing with amplifiers. I mean, we've done, in terms of Class D topologies, we've done, yes, as you asked before, I mean, we've done designs where we use some monolithic chips from, existing chip suppliers, but we've also done, 2-level PWM, 3-level, filterless PWM. We've done, you could say, analog input Class D amps. We've done digital input Class D amps. Actually, that was direct digital to Class D, amplifier for mobile phones. So we've even done a Class D amplifier, headphone amplifier with Class D, which I think we're probably one of the only companies ever to have done. So we work with lots of different technologies, and it really depends on the application, what topology and what technology we choose.
Do you think that the terminology digital amplifier is misuse of the word digital?
Yes. Yes, absolutely. I mean, that's a very good point. I mean, lots of people they think that D in Class D stands for digital, but that's not really the case. It was basically just the next letter in the alphabet after Class A, Class B, Class D, then came Class D. It doesn't really mean digital. Of course, and the other thing is, people think, well, it's either on or it's off. So, that's like binary, right? That's like what you do in a computer. Either, your transistor is on or it's off, right? So it's 0 or 1. So it's digital. But it's not really the case, because you can say, let me not get into that, into those details. But let's just say that a Class D amplifier is not a digital amplifier. It's very much an analog system.
Yes.
Very good. Yeah, let me talk a bit about our strategy, where we focus as a company. So first of all, of course, as I mentioned before, we are present in several different segments. We have customers in many different segments. But over the last 5 years or so, I would say we very much focused on becoming specialists in you can say, providing solutions for active speakers, as well as, you can say, rack amplifiers. And with rack amplifiers, I also mean you could say hi-fi amplifiers or streaming amplifiers and things like that. But really, we focused a lot on solutions for speakers, whether they be subwoofers for consumer use, or whether they be big pro line arrays, or small studio monitors, and products like that. The other thing that we really focus on is what we want to be is a flexible, competent technology partner. And I think the key word here really is flexible, and I'll get back to that in just a few minutes. And then the third thing is cost competitiveness, and I think that's one of the things we've really worked a lot with over the last I would say 6 years or so, and that's because you can say we do realize that we are and our customers are in the electronics industry, and while the electronics industry is a competitive place to be, so if you're not cost competitive, I mean, you can have very nice products, but that doesn't really do much for you. And it's also been, you can say, you mentioned before our heritage with B&O. Obviously, when in the past, when people heard, oh, you're part of Bang & Olufsen, I mean, the first thing that comes to mind is, well, then you got to be very expensive. So it's obviously been, as you can imagine, it's been a bit of a stigma that we've had to work with for many years. That's also why I think you can say separating from B&O was a very good thing, because we've actually never, as ICEpower, we've never had the intention of being a premium or an expensive solution. We've always had the intention of providing very good technology at a price that meets the expectations of the market. So that's also a very important part of our strategy, is that we is to be cost competitive in the solutions that we offer our customers, because if we are not, our customers are also not competitive in the market. So let me talk a bit more about flexibility, and I apologize here for all the words here. I'll try to limit it a bit. But basically, when we mean flexible, what we mean is that you can say we see ourselves as a company that has a lot of different IP, a lot of different technology platforms, and a lot of you can say skilled engineers. And basically, we let our customers choose how they want to engage with us. What are the services? What are the competencies? What are the products that fit to their particular needs? Because one of the things we've learned over the years is that you can say not all customers are the same. Each customer, and not just each customer, but each project from each customer is unique and has unique requirements and is a unique situation. And that means that what works well for one project with a customer is not necessarily the same that works well for the next project with that customer. And what that means is that we have customers where basically they design by themselves using our ICs, our chipsets. And on the other end of the spectrum, we also have customers where when they lack the resources, or if for some other reason it makes good sense for them, we do the complete design for them on a turnkey basis. So that's quite a broad spectrum of you can say possibilities. And I think that's, again, as I mentioned before, it's one of the reasons we're doing this is that we and our customers have realized that to really stay competitive, we all need to focus on what it is we're great at, and then where we can differentiate and add value. So working with us allows our customers to really focus their engineering attention on the features and technologies that help them stand out, and then let us do for example, amplifier and power supply bits.
Yeah, as the sales and marketing director, I guess there could be a little bit of you have to be careful, and I guess you come from engineering background, so you understand the risks in terms of there's certain customers that are small but maybe not capable, and you don't want to give them this open business model to just buy the IC and then have unlimited support services. So
of course.
You have to be careful as to, you're almost like you probably interview your customers to help you pick which ones. So it's more of an integrated partnership rather than just a sale in this relationship.
I mean that you're absolutely right. I mean that is how we see it. I mean whenever we engage with a customer, whenever a customer comes to us and has a project or something they would like to discuss with us, we always start with, as you say, an interview, figuring out what exactly is it that the customer is wanting to achieve. What is really the key success factors for this customer, for this project? What are their, you can say, internal capabilities? What are their, you can say, what are their commercial expectations, and so forth? And then based on that, we figure out, okay, what is the solution that makes sense in this particular case? And you're absolutely right. I mean, there are, of course, customers where it doesn't really make sense for them to start a design using our chipset by themselves, because of course there's always a learning curve. So if they're just doing one or a few products and the volumes are not that high, it typically doesn't really make sense. And the other end of the spectrum, of course, a turnkey design where we go in and do a complete design. Well, if the volumes are not that high and the customer is you can say, doesn't have the budget for investing in product development, well, then it also doesn't make that much sense. But then we have other solutions that we can offer. So I'm going to get back to that in just a few slides here.
Mm-hmm.
Okay.
So basically, what we want to do is we want to assist our customers really in differentiating their products and help them bring innovative products to the market.
Very good.
Yeah. So again, cost is, as I mentioned, is always a factor. It's always important. I've never met a customer that says price is not important. So it's something we have worked significantly with and continue to work a lot with. And for us, I think it really breaks down into two different buckets. So one, of course, is the manufacturing setup. And as I mentioned before, we built today in Thailand. We actually have two different EMS partners in Thailand, both in Bangkok. One is called SVI, the other is called GPV. And those are partners we've been working with for several years. And that means we have a very good collaboration with them. We have a very strong partnership also with the management teams of those EMS partners. And we've spent a lot of time and effort putting in place, you can say, our own quality control systems, our own testers, and so forth, on top of the, you can say, system and processes that they already have in place. So that's a big part of our, you could say, cost competitiveness. That is the whole, very cost competitive setup that we have in Thailand.
Okay.
But the other thing that is equally, if not in some cases more important, is how you build your product. Because at the end of the day, the production partner needs to put the boards, the components on the board that you have specified, and if you, so we are the ones who specify what components must go on the board, right? So that means we actually control the majority of the cost through the engineering and through the design of the products. So that's also a very key component, is how we engineer our product, and that's really become a core competence for us over the last couple of years. Is really our ability to design solutions and meet a particular cost target.
That's an interesting thing, and you say it's come about in the last couple of years, which is what I've noticed being in Asia for the last 13 years. Is there's not a lot of hardware engineers from the West that understand design for manufacturing. So
Yep.
Would you say this is a skill that you've added because it's just maybe not something? Okay, very cool.
Absolutely, because it's you can say again, coming from the heritage of Bang & Olufsen, if you go back let's say 10 years, we used to be told by customers, well, you guys have very nice technology, you have very nice solutions. It's just a pity they're too expensive. And when you hear that enough times, then you kind of get tired of it, and that's when we decided to do something about it. And I think you're right. It's probably also a mentality issue, and it's also probably a question of, I don't know, you could say what they teach you in school, so to say. I mean, I also went to engineering school here in Denmark, but I don't recall any single course where anybody really used the term cost price. We learned a lot about technology, a lot about math, a lot about electronics, but not really a whole lot about cost prices and how you design things for cost. Mm-hmm. Maybe it's different now. I don't know, but that means it's been a skill set we've had to learn, and we've spent the last, I'd say, probably 6, 7, 8 years doing so, and it really is. It's not necessarily an easy thing to do, because it involves it's both a question of choosing the right topology, as I mentioned before. You can't just use the same topology for every single design. You really need to choose the right topology for the task at hand. You need to choose the right components. You need to know what are the different components available. What is the pricing of different components? You need to work very closely together with the sourcing team already in the early stages of the design. So those are, you can say, those are skills, and those are processes that we have become very good at, I believe, over the last 6, 7, 8 years.
Okay. Well, if you're leader on the pack on costs, then you must be doing something right.
Yep. And that's something we do indeed believe that we are. So it also means that, you can say, since we have a lot of different platforms already in production, whenever we engage with a customer that has an idea for something they want to build, in most cases we already have a platform that comes very close to what they're looking for, and where we already have, you can say, established cost price, and we know pretty much what is it going to cost to build something for a customer already when we start engaging with them. So that's also a very important thing. So you can say this combination of having you can say engineering here in Denmark with access to a big talent pool, together with, you can say, having very competitive sourcing in Asia, is what enables us to provide very competitive products for our customers.
So is there somebody from Copenhagen with the unfortunate task of having to live in Bangkok to be the eyes and ears on the ground there?
Well, I'd say that's pretty much all of us in the sense that I'd say well, obviously not in 2020, of course, that's been quite difficult, but in general, there's always somebody from ICEpower present in Bangkok with our EMS partners. It's not always the same person, but it's we kind of revolve who's out there, but there's pretty much always somebody out there, either for introducing new products to production, or for quality control, or for maintaining testers, or whatever. There's always somebody from ICEpower present in the production.
Okay.
Yeah, and that's another thing that's important for us, and I think that it always has been, is quality. I think that's also something coming from a legacy of being part of the Bang & Olufsen group, meant that we've always had a very strong focus and dedication on quality, and when we look at our data over the last 20 years, we've actually achieved a field return rate of less than 0.3%. I think it's actually only 0.2%, and that's a combination of several things. So it's design, getting the designs right. So obviously, when you've done something for 20 years and you've shipped millions of units, that gives you a bit of insight into what works and what doesn't work in the field. What is it that actually happens in the field with the product we do? And you can say we've now had 20 years to roll all of that experience into our design and verification processes. So whenever we design a new product, we have very, rigorous testing regime for how do we test products at different stages of development to ensure that all of the, real-world failures that can occur are caught already in the design stage. So design verification, design validation is a very big part of what we spend our engineering time on. But it's also a question of choosing. I mentioned before, we really design for cost, and we try to choose the most cost competitive components. But of course, there are still compromises we are not taking. So there are always some key components that are, that can really have a bad impact on your reliability if you go too low, so to say. So for example, on electrolytics, we only work with brand name components, and so forth. Then the last thing is production testing. So as I mentioned before, we actually, one of the things we've also developed is our own inline manufacturing test system. That means every single unit we build is very thoroughly tested in production before it's shipped to a customer. That also means every single board we build has its own QR code. We have full traceability on every board, every component, and every board we build goes through high-pot testing, full automated functional test. Then a portion of that goes through burn-in. Then we do a full functional test again, and if anything fails, then during the second functional test, then that whole batch will go through burn-in.
Very good.
Yeah.
Yep.
So that's a bit of background on who we are and what we do. So let me talk just a bit about the resources and capabilities that we have and that we offer to our customers. So today, you can say our internal design team basically covers all of the different aspects that you need in order to create good audio products. So we have a big team of software engineers capable of doing both. You can say DSP development algorithms and so forth, but also you can say audio over IP, both AVB, Milan, Dante, just to name some examples. Control of products over IP, GUI design, etc. So all of these things are aspects that we incorporate into products for our customers.
What is AVB and Dante?
Well, those are, you can say audio over IP protocols. So, AVB is actually, it stands for audio video bridging. I think today they actually call it TSN, time sensitive networking. So that's basically an audio protocol that you use increasingly, especially in the pro audio and live sound for transporting audio over Ethernet basically, but also for doing control over Ethernet. So imagine you have a big live sound setup. Instead of running, you can say analog cables out to every single speaker or in the line array, you can actually run Ethernet cable, and then
Right.
provide both the audio data as well as the control of each particular line of element over Ethernet. Dante is the same thing. That's a proprietary standard, but it's become really popular in the last years. Many companies are using that. That's also something we support. So that's not our technology. That's say a third-party technology that we support.
Mm-hmm.
Got it.
Then, of course, hardware engineers. That really is our core. That's where we come from. Class D amplifier design, switch mode power supply design, but also digital hardware design. And we do everything there from schematic design, layouts, and then again, as I mentioned before, test and verification is really a big part of the effort that we do there. Mechanical engineering, both ID design, mechanical construction, but also thermal design, thermal simulations using, for example, tools like ComSol to make sure that you can imagine if you're trying to put a multi-kilowatt amplifier into a small chassis, then thermal design and thermal simulation become very important.
Yeah, I've had some cone manufacturers in Malaysia and Dongguan ask me for, do you have fireproof speaker cones? And I'm sure the heat's all coming off those amplifiers in these pro audio applications. So it's
yeah, that's true. That's true. Yeah. So those were some of the capabilities that we offer our customers and that we possess. And basically, so let me talk a bit about some of the products and services that we offer. We talked a bit about this already, but overall, you can say there are you can kind of divide it into there are 4 different, you can say, overall approaches that we work with our customers. So in one end of the spectrum, there is what you asked before. Well, we do our own audio ICs, and we have customers that do their own designs based on those ICs. Typically, that's when the customer typically if they have their own like preamp, or if they have some specific packaging concerns, or they might have other reasons why they want to be in very tight control of their product design and product production. Then they can use our technology and we, of course, provide support, and then they go and design and build their own product.
Mm-hmm.
To the complete opposite end of that spectrum, what we are increasingly doing for customers is, you can say, full turnkey designs. And when we say that, we really mean turnkey. So it's typically, I have examples of basically having met somebody at a trade show and they drew kind of a little drawing on a napkin. We want an amplifier. It has to basically look like this. We want these connectors. We want these specifications. Is that something you can do? And we looked at it and said, yes, that's something we do. And then we took it from there, basically a sketch on a napkin, all the way through, you can say, concept development, prototyping, testing, verification, certification of the product, both EMC, safety, compliance, introducing the product into manufacturing with our partners in Thailand, getting all the mass production testers set up, etc., and then into mass production. And then when we're at mass production, it doesn't stop there. It really is a full, you can say, cradle-to-grave service we offer. So even in mass production, we take care of everything in terms of, sustaining engineering. For example, imagine you have a situation where, I don't know, a semiconductor factory in Japan goes up in fire, and then all of a sudden you're scrambling to find 80 converters and DA converters for your products. Well, if you work with us on a turnkey basis, we take care of that. So that's actually that's something we're actually spending significant resources on right now, is doing redesigns of several of our customer products to make sure basically that we can continue supplying them, even though there are parts that are now unavailable in the market.
You gave away one of your secrets just there. If people are watching the the news in Japan lately.
So so that really means that when we do turnkey for people, it's we engage, as you said, it really is a partnership. We engage early on in figuring out what is it really the customer wants. We work very collaboratively on the whole concept development, figuring out what are the specs they're looking for, what are the platforms we have, and typically that's kind of an iterative process where they ask for something, we provide some feedback, we guide them a bit on, if you're asking for this, but if you did this instead, you could actually get better performance or get a cost saving or whatever. And then typically we collaboratively end up with what is the optimal specification for the customer's project. And then we take it all the way from there, and then basically through to mass production. And then from there on, you can say it's from the customer perspective. All they have to do is provide us with forecasts and POs, and then we get them the products that they need. So those are two opposite ends of the spectrum, you can say. And then of course there's also a lot in between those two opposite ends. And one of those things is, you can say, amplifier power module. So actually the majority of the customers we have, in quantity at least, they use some of the, you can say, off-the-shelf amplifier power modules that we offer. So that's what I mentioned before. We have a lot of different existing platforms that we offer our customers, and those are very popular for good reasons. First of all, it's time to market. Basically, you can, if you have a project, if you're looking to build an active speaker, if you're looking to build a hi-fi amplifier or rack amplifier, you can call us today and you can have samples tomorrow, and that basically enables you to get started testing, get started developing your product right away. So you don't have to worry about anything, everything, from the AC plug to the amplifier output to the speaker. You don't have to worry about that. You can focus your engineering bandwidth on the Bluetooth connectivity, the Wi-Fi, the DSP, the speaker design, or whatever are the aspects of the product that you really want to differentiate yourself on. Then we take care of all of the, you can say, the power portion. So it really gives, fast time to market, low risk. It's proven designs. We work with very low MOQs. There is no investment in using these modules, and you get very good performance. So they're very popular for many different applications. And then finally, audio software. Obviously, as I mentioned, it's incorporated into a lot of the turnkey solutions we do. So that really is the majority of the software work we do. But also, in addition to that, we actually have what we call an embedded audio DSP solution. So that is, it's basically a DSP processing solution that we deploy on, you can say, notebooks, smartphones, tablets. So it's, So those are the overall, you can say, four different product type and service offerings that we work with our customers on. Of course, there are also hybrid versions, and we do custom modules, and there are also all sorts of variations in between this.
So there is a secret menu.
There is a secret menu, yeah. There is. But again, coming back, that's what I mentioned, coming back to flexibility. And really what we want to do really is sit down and have a conversation with the customer about what it is they want to accomplish, what is their situation, and figure out what is the best way we can help accomplish what they're looking to do.
Yeah, no, it's a universal thing. Is good business matching makes the healthy relationships.
Exactly.
Okay.
Good. Yeah. So a bit more detail on these different product types. So on the audio ICs, the latest version, the latest chipset we have is called ICEdge. I mentioned we've done many, I think 12 different IC designs over the years, and this is the latest one we've done. Really what it is, it's a complete Class D amplifier platform, basically. So it includes everything you need to have in a Class D amp in terms of the modulator, the feedback, all of the you can say housekeeping, protection features, monitoring, all of that into one system, one self-contained system. The only thing that is external is the power MOSFETs. And the reason for that is to make it scalable. So that basically means that you can use that same chipset and create amplifiers all the way from like 50 watts to potentially up to 7 kilowatts. And that's quite unique. So it's a very open, very flexible architecture. So you can actually implement many different sorts of feedback loops and modulator types. You can do fixed frequency PWM. You can do self-oscillating designs. You can do many different types of Class D topologies with this chipset. Mm-hmm. And basically, what that means is we can actually offer, in all the benchmarking we've done, what we find is we can offer superior audio performance to pretty much any other, you would say, Class D amplifier available. But at the same time, we can approach the cost of, you can say, monolithic integrated amplifier chipsets, but still having the better sound quality. So we use this chipset, of course, in our own products. So several of our modules, several of the turnkey designs we do are based on this chipset. But we also, of course, offer this as a standalone chipset that people can work with on their own. Power modules, yeah, again, they're plug and play, very easy to integrate, very fast time to market. There's no investment required, low MOQs. You can contact us today, you can have samples tomorrow. They're all pre-approved for safety in UNC, so that means getting your safety approvals on the final product is a lot easier. We've been building these for many years, so we have high reliability, very low field return rates, excellent sound quality. And because they're based on Class D technology, switch mode power supply technology, they're all very, very compact and have very low heat dissipation.
Okay.
Yeah, so for example, the latest series we've done is called the AS series. So that means amplifier, power supply. It has pretty much all the housekeeping functions, all of the system level functions you need on board for building, active speakers or amplifiers of pretty much any sort. So ERP compliant standby, universal mains, regulated auxiliary supplies, pre-approvals. Yeah, I think I've said that already. Competitive cost. So I'm not going to go into details with every single module we do, because then I think all of us would have gray hair before I would be done. I'm not going to bore you with those details. But the picture I just want to paint for you is the breadth of the portfolio we offer today. So today, basically, we have existing solutions from all the way from 50 watt all the way up to several kilowatts. And we have solutions that are single channel, 2-channel, multi-channel, and basically you could say in increments like from 50 watts, 100 watts, 125 watts, 200, 250, 300, 500, 700, 800, 1200 watts. So what that means really is that what we find is that in most cases when we talk with customers, we have something that comes 90% close to what it is they're looking for. And of course we have, for some customers, they want those last 10%. That's fine. Then we either do a turnkey solution or we customize the product if the volume is, justifies it, of course. So of course there's always a commercial consideration there. But what we find with most customers is that if it's 90% of what they're looking for, then it's better for them just to go ahead, and get started, and they can have samples right away and then get started on the product development.
Mm-hmm.
Turnkey, yeah. So as I mentioned, we do complete turnkey solutions, but of course we also do joint development. We have customers where there are particular aspects of a product that they want to participate in. They might have their own preamp, they might have their own DSP algorithms they want to incorporate. Then it becomes more of a joint effort where they participate, we participate. But again, it all comes down to, for each product, what is it really that makes sense in this particular case. So we're able to do full, custom product design. We do all the prototyping, all the introduction, new product introduction with the manufacturing partners. We take care of all the supply chain management. We take care of all the project management of the product. We do the same also for backplates for active speakers or subwoofers, PA speakers, studio monitors. And these are just a couple of examples of what we've done in the last couple of years. So we've done some streaming amplifiers, using ADB for audio over IP streaming and control over IP. We've done actually also our own 5-port AVB switch, network switch. We've done I/O boxes, so analog input/output boxes for getting data on and off the network. We've done some aftermarket automotive amps for a customer, and then of course we've done a lot of different, both 2, 8, 4, 16, 12 channel Class D amps, both for hi-fi, hi-fi home audio space, but also for could say residential home automation, as well as commercial audio installation. Then also an area that we've seen a lot of interest in the last years is what we call high C, low C amplifiers. So these constant voltage line amplifiers that can run, that you use typically when you have very large spaces where you need many speakers. What you do is you run these constant voltage lines of either 70 or 100 volts signals, and that's also something that we can do with our technology, and also what we see there is typically there's a push toward flexibility again, that a lot of customers like to have amps that you can use both for traditional low C, 4 ohm, 8 ohm speakers, but also for the high C application where you need the 70 or 100 volt output. So we also have technologies where we can actually do amps that you can use in both of those use cases.
The high Z one speakers are in series. Is that the point?
They're in parallel. Yes. So typically you run one wire basically around. You can imagine if it's a conference scenario or a big restaurant, and you just want to play the same signal and all of those. You just want one wire basically, or two wires throughout that entire facility, and then each speaker is coupled in parallel through a transformer to that step-down transformer to those wires.
Okay. They run through a transformer. So I was thinking in parallel the impedance would go very low, but they're actually transformed off a high voltage line.
Yeah. So you can say there are multiple benefits of that. It's one thing is installation. So you keep it at the 70 or 100 volt RMS because that means it's below the the high voltage requirements. So that means anybody can basically run those wires. You don't need any authorization to do that. And the other thing is it's cheaper just to run one basically a wire instead of having to run individual wires to each speaker. So those are typically the reasons why some installations are done in that way.
Okay.
Yeah, and then on the embedded audio side, again, as I mentioned, what it is really is it's an audio post and pre-processing sound suite that we've developed. So what does that mean? That means post-processing really means optimizing the sound quality and the sound pressure level that we are able to generate from, you could say, the very small speakers that you have in portable devices such as notebooks and tablets and so forth. So those speakers they're typically not very good. They're not very expensive, and they're very small. But by doing some intelligent digital signal processing, you can actually improve the sound quality of those very dramatically. The other part of that is the pre-processing. So what is that? Well, that's processing we apply on the microphone side. So typically like echo cancellation, noise suppression, beamforming, to really enhance both, you can say, the listening experience, the speech intelligibility, but also a lot what we use it for is to improve, you can say, the hit rate of virtual personal assistants such as Cortana or Alexa, things like that. So really, it's a complete solution we've developed that you can run both on Android, you can run it on Windows, you can run it on Linux, for pretty much any type of portable device. Okay. So of course this is very specific to those types of products, but again, it's also you can say a technology and a competence that our customers in other segments they are able to tap into, and we can utilize these technologies and these competencies also on what we do for example, the home automation or the commercial audio or the pro audio space as well.
Okay, that might be a better category in this year.
Well, yes. Well, I mean, I think it's no secret that pro audio has been difficult this year.
Yeah.
That's why I think from our perspective we're very happy and we're very fortunate that we are present in different categories, right? Because what we see is, as much as the pro audio side has been heavily impacted, there seems to have been a trend on the home audio side and home automation side where this I don't know what you call it, this cave mentality, right? That you're when you can't go out and you have to stay home, well then you buy gadgets, and so that's it seems like the customers we work with that do products that you somehow use in your home, they've had a very good year.
Yeah.
They've not really been impacted.
Yeah, no, the Logitech sales are up 60% or something year over year with their. So yeah,
I'm not surprised to hear that. so that's cool.
Yeah.
Very good.
How many slides have we got left?
I think we're more or less done.
Okay.
Yeah. Let me skip this one. So this is just some of the algorithms that we do on the embedded audio side.
Oh, this is good stuff.
Yeah. So basically, yeah. So it's basically a collection of algorithms. Both bass enhancements, equalizers, limiters. Dynamic processing, levelers, treble enhancement, but also you can say virtual surround sound processing, and basically using head-related transfer function processing and crosstalk cancellation to process a surround sound signal, down mix it into a stereo signal, either stereo speakers or headphone, and still providing that, you can say, surround sound sensation of the content.
Yep.
Okay. Good. That's it.
I want to pile in with a few questions. So, digital amplifiers just made the faux pas. Class D amplifiers, I see a lot of tons. So if I go into AliExpress or something, I want to pick up a cheap amplifier for around home. You've got a Texas Instrument, I think it might be like a 6133, something like that. And this is your bog standard digital Class D amplifier. What does that differ from what you're doing?
Well, in many ways, it differs. So, of course, we have a lot of respect for TI. I think they do great stuff as well. And there's actually very interesting background story there as well. But I'm not, because actually the core technology that they use in their digital amplifiers, sorry, now I said it myself, but their Class D amps, it actually also emanates from the same, some of the same research at the Danish Technical University. So there was a separate company that was set up all the way back in the early zeros that ended up being acquired by Texas Instruments. So they've actually had a research and a development facility here actually it's just been 500 meters from our office for the last many years.
Okay.
But anyways, that's another story. So we have a lot of respect for those guys, and I think they've done a lot of good work as well. Absolutely. Okay. I think they've gone a different route. They've very much focused on the monolithic chips, putting everything into one IC, which there are definitely, there are many advantages. It makes it easy to develop with for the customers. Cost-wise, it typically also ends up being less expensive. But on the other hand, some of the downsides are you're very much locked in. So for each, you can say, power level you want to do, you need to do one chip using one specific silicon technology.
Right.
Whereas you can say we've gone a more flexible route. We've done a chipset that incorporates all of the intelligence, so to say, but keeping the MOSFETs externally, and that means scalability. Yes. It also means we can take advantage of, they're constantly, you say the performance and technology of MOSFETs also keep improving. So that also means that as new MOSFETs come into the market, we can also do better performance. And typically you get more silicon area in a separate MOSFET than you do if you have to put everything on one die. And you can really, you can choose optimal silicon processes for each particular part of the chip. So if you do a monolithic chip, you have to choose one silicon process, both for all of the sensitive, you can say low-level analog electronics on the chip, as well as for the high power.
Right.
What we do, for example, with the ICEpower chipset is we use a very low noise analog process for the controller. Then we use a very special high voltage silicon on insulator technology for the gate drivers. And then you can say we use whatever technology is optimal for the MOSFET. And that means you can really optimize the silicon process for each particular element of the amplifier. So I think that's one different, you can say, philosophy, one different approach we've taken. But then also the other thing is you can say the core, let's say the core modulation and feedback technology that we use. So most of the TI amps use fixed frequency modulation, and up until I still think today they use all of the feedback in their amps is taken before the output filter. There may have been some changes there, but that's at least that's been the case so far.
Yeah.
And whereas you can say we've taken a different route, we've always mostly done self-oscillating amplifiers and always with post-filter feedback. And from our perspective, there are many advantages to doing self-oscillating amps with post-filter feedback.
Yes.
So having the filter as part of your feedback loop offers many advantages. So first of all, it means that it reduces or almost removes your the effect of the load on your frequency response, because you'll have that controlled as part of your feedback loop. It also means you can get a very, very low output impedance of your amplifier. But also you can say the output filter itself actually also contributes nonlinearities, because capacitors, well, in a textbook, when you go to engineering school and you learn about components, well, they're all nice and linear, that's fine. But in the real world, capacitors and inductors, they're not ideal linear components. They do add distortion. And that's why, having them inside of your feedback loop means you can actually compensate for that distortion.
Yep, beautiful.
So those are some of the different. I mean, we could easily do a separate session talking at length about different feedback topologies and pros and cons of how you can design.
The output filter consists of inductance and capacitance primarily.
Yeah.
Is it?
Yes.
Is it a series inductor and a capacitance to ground? Is it that kind of a structure?
Yes, basically yes. Yeah.
Something like that. Okay. Yeah.
It's a low pass filter, basically for demodulating the square wave outputs from the output state. Another thing is typically a lot of the monolithic chips, due to the technologies you use there, they're typically single rail amplifiers. So that means you just need that means typically if they have to be BTL amplifiers, because otherwise you get DC on the output. So you can't really do a monolithic single-ended amplifier. Most of the amps we do, not all, but most of them, they are using dual rail power supply. So that means we have a plus-minus supply, which we can do because of the topologies we use.
Yes.
And that means we can also do single-ended amps that you can then bridge. So there are some. I think there are different pros and cons. I think the guys like TI, they're doing a very good job. They have very good technology as well, and those amps are very good for some applications. I think what we offer has other advantages and are good for other applications. So typically we can do better audio performance. Typically both in terms of distortion, we can get very, 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 very low distortion with our technology. Also in terms of noise floor, I mean, we have, for example, our big 1200 watt amp, I think has a noise floor of, I believe it's around 25 microvolts.
25 microvolts with a swing of the maximum swing?
That's around 70 volt RMS swing.
Wow, that's phenomenal.
So that's a signal to noise ratio of, well, of course I don't have the data sheet right in front of me here, but it's getting close to 130 dB.
Yeah, that's incredible.
And we even have some things in development that are not launched yet, where we are even improving that. So we have prototypes here in the lab using some of our latest technologies that are, I think, up to around 134 dB signal to noise ratio.
Yeah.
So that kind of performance is difficult, if not impossible, I would say, to achieve.
Which I guess leads me into the next question is, when we talk about sound quality, especially for high power stuff, what are the key characteristics that the metrics for what means sound quality?
Well, I think sound quality is a very subjective thing. So it really, I mean, there are lots of, you can say, standardized things you can measure, which of course we do. Yeah. But at the end of the day, you have to listen to things. So we spend a lot of time also listening to the amps we do in our lab and making tweaks and optimization based on what we hear, not just what we measure.
What kind of things are you hearing then? I mean, what characteristics are we talking about? Distortion is easy enough to say. Is there other things?
Well, it's a question. Well, it's many things, I would say. It's a question of stereo perspective. It's how dynamic is it? Are there any strange artifacts or any unpleasantries in the sound as you listen to it for a longer period of time? So some of the objective things we measure are, of course, noise floor, where if you're talking about a big pro amp, you can easily imagine some of the big line arrays, you typically run very, very sensitive drivers, especially the compression drivers have very, very high sensitivity. So any noise present on the terminals of such a compression driver is audible. So you want to have a very high signal swing. You want to be able to really peak some very high voltages to have that dynamic impact. But at the same time, you don't want it to go whenever you're trying to do quiet. Right? So So signal to noise ratio and having a low noise floor, I think, is very important, both both for big pro audio speakers, but also for studio monitors. Imagine near field studio monitors where you're sitting at maybe just a meter's distance. If you have lots of noise on the input there, it's also going to be audible. So those are very important. And then, of course, distortion. Having a linear frequency response that is load invariant is important. Having distortion characteristics that are, say, nice, low intermodulation distortion is typically something that is overlooked. But harmonic distortion is something that it can sound unpleasant, but still it's somehow, I don't know, it's still somehow related to the audio signal, right? Because it's a product essentially of the audio itself.
Yeah,
intermodulation distortion, on the other hand, can be completely, you can say, uncorrelated with the actual audio signal itself. So that can sound really unpleasant if you have too much intermodulation distortion. I think that's one of the things that we also excel in, is the very low intermodulation that we can accomplish with our topologies.
So we just learned anyway that the layman's key characteristic of an amplifier is power, output power. And they've also taught us that signal to noise ratio is actually a really critical factor. What else can we talk about when we're in a group of amplifier designers and we want to sound like we know something?
Well, I mean, those are two of the important ones. There is, but there are others like output impedance.
Right.
Output impedance, having bandwidth, of course, having both. But one thing is having a flat frequency response with a nice phase characteristic. But the other thing is that we're also seeing interest in these days is having an extended bandwidth, going above 20 kilohertz. So that's also something that we can do with some of the newer technologies we have. We actually go all the way up to 100 kilohertz in some of our designs. Whether how much you hear that is a separate topic, but you're seeing more and more, you can say, high-res content with 96 kilohertz or even higher, 192 kilohertz sampling rates, where it doesn't really make sense to have that kind of sampling rates on the content side if the rest of your signal chain can't really reproduce it. So there is also interest, I'd say, in having very high resolution, very high bandwidth DA converters and also amplifiers.
Yeah. So in terms of, you showed the chip itself, what sort of supply voltages is that working at? Is that like a 3-volt logic type of a thing, or you have?
Well, the chipset itself, basically it needs a couple of different voltages. So typically it needs, I believe, somewhere between 5 to 8 volts for the analog circuitry. It also needs, what is that? I think it's a plus and a minus. It's a plus 12 volt and a minus 12 volt reference to the negative rail for the gate drivers. I might share if some of the engineers hear me, they're probably going to laugh. But anyway,
close enough.
Close enough. And then you need the voltages for the power rails. And of course, the voltage for the power rail really depends on, what is the power you want to achieve, right? So it
can be 100 volts, so kind of thing like that, is it?
Yeah, well, I think one of the unique things about our chipset is that we're actually using a 300 volt technology for the gate driver. So that means we can in theory go up to 300 volts. You can say on the output stage. And that really is what enables us to, at least in theory, go all the way up to 7 kilowatt amplifiers with this chipset.
That's amazing.
Okay.
Hit him, Dave.
All right. Yeah. So I guess just on some interesting tidbits. Obviously, portable audio. You talked about mobile tablets, notebooks, headphones are a big thing. Is your DSP, is that available? Are people using that in headphones? Is it on the horizon? Is that segment something you're looking at? The headphone segment?
Well, that's a very good question. I mean, we of course in the notebooks, in the tablets that our DSP solution is deployed on, if you use the headphone output on those products, well, yes, then you can use our processing on that headphone output.
Okay.
So in short, yes. Are we looking at separately doing something for headphones? Not really at the moment, to be honest. But that could be an interesting area as well, because I agree with you. I mean, there seems to be increasing interest in head-fi and really doing high-end audio headphones.
Yeah.
In particular, I think some of the you could say some of the virtual surround sound processing that we do is can be really amazing actually on headphones when you have surround sound content, down mix it to headphone, but still retain that surround sound experience. It's actually quite a powerful, I could say, effect.
Yeah, is it just a curiosity question? In headphones and notebooks, is there gaming customers? Because we've seen, I mean, gaming's been around now 30 plus years, so there is actually some money in it these days. You're seeing gaming headphones selling for $400 or $500 US. So is that something you guys are looking at as well, gaming space?
Well, we have customers deploying our solution on gaming notebooks.
Okay.
Are we doing something there ourselves? Well, not really at the moment, no.
Okay.
But it is an interesting space, absolutely.
All right. Well, I guess yes. Your company's privately held.
Yeah, so we're privately held. So you can say I mentioned before that we used to be part of B&O. When we separated, the company was acquired by the management team. So we're privately held today, and say controlled by the management team.
Okay. Yeah, I think just a personal note, the time I visited you guys 10 years ago, I think we also visited the TI office with their amplifier division at the same time in 2010.
You might well remember.
Yeah. Okay. So yeah, I think what I take away this as a theme is you've got this great brand equity. So like, and you said, and so with that brand equity, which has been established by performance and support, but I think the key that people are missing that is probably, there's a little gem there, is that you guys are competitive on price as well. So you talked earlier that people are sometimes scared away because of the ICEpower name, but in reality, you're telling us that you've got the magic formula of superior brand equity, superior performance and support, but then very competitive pricing. So it sounds like you guys are in a very good position to take market share.
Correct, and that really is, as I mentioned before. As I mentioned before, what we've heard from customers all through, you can say, the existence of the company as well. You have amazing technology. It's very cool stuff you do. It's great products, great reliability, quality is good, but price is the challenge, and that's why I would say it's been a focus. I would say, especially in the last 6 to 8 years, really we have worked a lot on the pricing side, and I would say that. I think I'm pretty confidently stating that we can compete on price also against most other solutions in the market. So we are finding today that that's usually not the reason for not working with us.
And customers typically have the ICEpower logoed on their product as well. Like they want to carry that brand esteem in.
It's a mix. It's a mix. So as you can imagine, we have many customers doing that because they feel there's value in that, and they feel they are proud to showcase that they're utilizing quality technology, quality components in their product. We also have customers that don't for different reasons, but you can imagine some of our customers, they come with a different background, a different brand. They might have a brand legacy themselves of being amplifier companies, and for those reasons, sometimes they prefer not to do it. So it really is a mix.
Okay. All right, then I guess how can people hit you? What's the contact info, social media links? If you don't know them off the top of your head, we could always put them in the description. Yeah, well, basically, you can, of course, you can look us up on our homepage, icepower.dk. You can contact me directly. My email is sol@icepower.dk. And also, if you have projects that you want to get started on, you can basically just go to our homepage and buy a sample through our web shop. So so that's also a very easy way to get started. And of course, whenever you do so, whenever you have a project, we have application engineers that are ready to help you and work with you. So we're very passionate about audio. We're very passionate about music. We're always excited about new cool projects, and we're always here and always ready to help. Okay, very cool. Anything left, Simon? I think we've talked for about an hour and 15 minutes on ICEpower. So
yeah, I think we've used up all the time we have available, unfortunately. But fantastic. Very good to
All
talk
right.
to you. Thanks.
Okay, yeah. So Simon, thanks for joining as always, and Mads, a special guest calling in from Copenhagen. We really appreciate your time, and we'll put all the contact information below in the description. And if you like what we're doing, everybody, please hit like and subscribe. All that cheesy YouTube promo stuff. So, all right, thanks everybody. Have a great day.